see if this is better. Wow. Sure. Okay. All right. Oh, so leftover questions. 7-2, number 70. So what was it about this one? Whoever had this question.
Factoring it.
Say again?
Factoring it.
Ah, all right. So on the way here, what can you do with this division? There's a division there, so you can multiply by reciprocal. Okay, so let me cut some work out here. Bless you. So the thing that makes people make the most mistakes with factoring is you don't GCF when you should have GCF'd. Right, just a verb, a noun. There are two places here where you have to GCF to be able to do anything. So you always try GCF first. I mean, there's no GCF here, so I can just attack this doing what? Cubes. So little dude, big dude, go from there. Is that cool? All right. So either you know how to do that or you don't. It should be identification, should be the hard part. Down here, any GCF?
No.
No. So then I have to do what?
AC method.
AC method, I like it, cool. AC. 2 times 2 is 4, and make 5, blah, blah, blah. And then group it. You guys with me so far? Or trial and error. I feel like trial and error better. Because there's only one factor for 2. So there's not that many combinations to try if you want to do trial and error. So far, how are we doing so far? I mean, I think the big problem would be over here. But again, both of these, you have to do what first? GCF. Yeah, so like up top, you can take out a 2, and you're left with
4x squared minus y squared.
and then this, of course, is a difference of squares. I like it, cool. Right, so you can bam, bam, plus minus. And then on the bottom, you take an x out. That's as much as I can take, right? Because this only has one x. So you can only take one x out of the whole thing. So then I get x squared minus 2xy plus 4y squared. And what do you think this might be?
Probably the big guy.
Yeah, whenever you have a cubes in your problem, if you hit a trinomial that doesn't look like it'll factor, leave it alone. Maybe it's the big dude, it'll cancel anyway. Right? Don't tear your hair out trying to factor it. Maybe it doesn't factor. And that one, don't. Is that enough to get you going? Whoever asked that question? Who asked that question? Oh, is that?
Can you factor the other bottom one too?
Yeah. So there's. I don't know which way you like better, but by the textbook method is to do 2 times 2 and get 4, right? Because the first number is not a 1, so you have to take it into account. And then you need 2 numbers that multiply to be 4 and add to be 5. 4 and 1. And then you can rewrite the middle term using 4 and 1 as coefficients, right? And then group that then. 2x squared plus 4xy plus 1xy. What's it say? Oh, plus 2y squared. Is that cool? And of course, that's the bottom of that one. I'm not really lining it up really well. So the top will just be the little dude, big dude thing. Okay. Is that cool?
Yeah.
All right. So it's all about identification of method, and do you know how to do that method? So the number of terms tells you what to try. It's almost too nice to believe. 2 terms can only be cubes or squares if there's no GCF. That's it. That's all it can be. 3 terms. If the first number is a 1, easy. You just got to find the right numbers. If the first number is not a 1, oh shit. All right, you got to take into account first and then do almost the same thing and get to grouping. So there's 2 levels. Do you know how to do the method, and do you know how to tell when to do the method? Right? And of course, that's math right there. Math is knowing when to do what. That's the hardest thing. I'm sure some of you guys know exactly what I'm talking. Some of you guys said exactly that in the survey that almost everybody did. Almost everybody did the survey. Not quite everybody. And one thing I want to show you real quick from the survey while I'm thinking about it. Remember that I asked you to pick a random number?
Yeah.
Anybody know what the most picked random number was?
7.
It's always going to be 7. Every time I've done this, except for one semester when I had too many people retaking my stats class and they already knew the thing behind it. The human brain is weird. Probability and stuff is really weird to us. Let me give you a quick example while this thing is warming up. Go with me for a second, all right? Does everybody have a blank piece of paper?
Yep.
All right. Does anybody have a $50 bill? No. I'll show you a trick. It's gone. Take out a blank piece of paper. Write the day that you were born. So if I was born September 21st, I'm going to put a big 2-1 on the paper. You got me? Don't write the month. Just write the day that you were born, the number. If you were born the 7th, you write a big ass 7. Write it big because I need to see it when you hold it up for me. What I'm going to do is, what do you think the chances are that 2 people in here have the same birthday? The exact same birthday. You're both born on June 7th. Not the same year. Let's not go there. All right, that's freaky. So you might believe that it's more possible. Most humans would say, no. No, Jeff. No. How many people are in here? Don't hold them up yet. I got to go by month or else I don't know. How many people? There's like 40-something, maybe. Most 50 people in here right now. You with me? And how many days of the year are there? Holy shit. So the brain says, no, there's not going to be 2 people in here with the same birthday because the brain does not understand probability. It's not hardwired for it. So that's part of what happened here. The brain doesn't understand random numbers, which is also a part of statistics and probability. So your brain says, what's the thing that nobody else is going to pick? Sort of like if you ever watch Mythbusters. I love that show. They did the one about the first bathroom stall. Everybody passes it because they think everybody's going to pick it, and nobody picks it because everybody thinks everybody's going to pick it. Are you kind of with me? Yeah. The grammar got weird in that sentence, but oh well. Right? See how many people picked the number 1? Because your brain said everybody's going to pick 1, or there's a lot of people going to pick 1. I'm number 1. Nobody did. Of course, I almost changed the instructions to be a whole number, but I decided to leave it alone so I can always tell who my smart asses are. So I have 1 smart ass, and then 1 I can't really figure out. It's not really a smart ass because I asked for numbers 1. So whoever you are, maybe you had ESP about my birthday, the 21st. All right, so go with me here for a second. Where are my January babies? Let's come back to the birthday. January babies, hold up your papers. You see how this is going to work? 20th, 13th, 6th, 16th. I can't see. 17th. Oh, we almost had a match. So no matches there, right? How about my February babies? The 12th. The 13th. Look at that, man. So close. How about my March babies? 4th, 29th, 29th. There. I only have to go to March. Give me, wait, what's up? 21st and 14th. All right, so we already got a match. Let's keep going. January, March, April. Where are my April babies? 21st, 13th. All right. Where are my May? May babies. Holy crap, May is the month. What is 9 months before May? Let's see. Okay, that's really big. 10. Wait, sorry. Put it back up, Jordan. I couldn't see this. 16 or 6. 13, 26, 23, 31, 15. There was only 1 13. Yeah, 23. Okay. No matches there. Where am I at? May, June. June. 3rd, 6th, 5th. Oh, look at you guys. 2, 3, 5, 6. That's neat. June, July. By the way, happy belated. July 10th and the 23rd. All right, you're all coming up. August 22nd, 24th, 3rd, and 3rd. Look at that. Who are you? Do you guys know each other? No, you don't know each other. And you're sitting next to each other. That's awesome. So we got 2 matches when the brain said no. Because what the brain does is it says nobody has my birthday. But what we don't realize is any 2 people. So then the options increase. And when my options increase, my probability goes way up. So once you get about 30 people in a classroom, I'm always willing to put money. Today I would have put money. I would have put money down, but I'm still a teacher, so I'm always a little bit hesitant. But put some money down and say, I know that at least one pair of people in here will have the same birthday, and I would have made some money maybe. Where did I leave off? Yeah, so September, what's that, 19th, 12th, 17th, 5th, 21st. October, 27th, 25th, 1st. November, 7th, you have November. December, 61st, 19th, 15th, 20th, 16th, 23rd. You have a cluster. So we got 2 pairs of people. And the brain would say, no, it's not any chance. And we got 2 freaking pairs of people. One semester I had to go to like November and I started sweating a little bit, but then I got it. Right? One semester I got like 5 pairs of people. It's great. And one semester I had 3 people with the same. It's awesome. Anyway, so this is all kind of pointing to, when I say pick a random number, your brain is not going to pick a random number. It's going to pick it based off of certain assumptions. So this is not truly, we can't really be random. We can't. Random is some weird YouTube word nowadays, but oh well. All right, just want to show you that. That's one result from that. Let's see, where to leave off? Were there any other? Oh yeah, 7-4, number 70. Thank you for doing that for me. I would like to see that it works still. You know, so I always thought if I made you write a number from 1 to 365, it should be the same situation, you see? So I'm always curious. We won't do it, but let's see. Oh, yeah, let's do that instead of math. Jeff, come on. No.
Do it.
I just won't. Let's see. Je ne sais pas.
Parlez-vous français?
Peu français. Je parle un peu de français. That's about it. Je vais à la plage. My favorite French word is la corbeille, the wastebasket. It sounds like an old car. La corbeille, real Corinthian, doesn't it? It's a wastebasket is what it means. I love that. What do you have? I have a wastebasket car. Yeah, I do. This one, right?
Yeah.
So what's up with this problem? What's going on?
The LCD is already here.
Yeah. There's 3 parts to it, but the really nice thing is they already factored that last dude. So who's missing something? Yeah, this guy's missing an x plus 2. And this guy's missing an x plus 3. So now they all have the same LCD. Now the only ugly part about this is you have to foil, minus this. So it's minus 7x minus 19, right? At the end. You with me? That negative has got to distribute to both. So there's some places. So now foil that out, collect your like terms. And then the last thing you got to do is see if the top that you get at the end, see if it factors, because maybe it cancels with the bottom. Is that enough for whoever asked that question?
Yeah, I got something weird because once I factored, so like after I did all the factoring and combined like terms, I got 2x squared plus 10x plus 12 over x plus 3, x plus 2, and then I factored that, and all of them canceled out, and all I was left was 2.
Cool.
I don't know if that...
That's awesome.
Just seemed too simple.
And the way to check it is to just pick a number for x. Except, of course, what can you not pick for x?
-3.
-3, -2. So if you pick anything else. So I would pick 0 for x. If x is 0, what is this?
5.
5/3 plus
7.
7/2 minus 19 over 6.
Yeah.
Are you guys kind of with me? We're going to check your result. You got the answer of 2, which means it's independent of x. So no matter what x I pick, it should come out to be 2. So, okay, let me catch up to you. So this, to make an LCD, I multiply this by 2, multiply this by 3, and then leave that alone. 10 plus 21 is 31. No, Jeff. That's a neat trick. 10 plus 21 is 31. Minus 19 is 12. Over 6 is
2.
Yeah. Now that's not a proof, but I feel pretty damn good. A proof would be pick another value of x. And that still isn't really a proof, but if 2 worked, then you're almost certainly right. It's got to come out to be 2.
Okay.
Kick ass. All right. So let's get back into it. We're in section 7.5 now. Believe it or not. And by the way, I don't want like a crush of people to do this. You ran away before I finished printing it out for you, but if anybody else doesn't have the book yet, and I can print out a few copies of the homeworks if you want to come to the office after class. I see a lot of people shaking their heads, so I don't want like a crazy crush of people. All right, but if you need that, you can do that. All right, so here's what 7.5 is all about. There's 2 main ways to do the problems in 7.5. And let me show you the most basic problem in 7.5, which leads to one way to do it. And then we'll talk about what the other way to do it is. 7.5 is all about these Russian nesting fractions. And what I mean by that is fractions inside of fractions. Right? So thankfully we don't have fractions inside of fractions inside of fractions. You know, it's like inception fraction. So if I have you can do it, sir.
Oh, is it x minus 1 on top?
Say again?
What's the top denominator?
Is it x and y?
Oh, x, y.
Okay.
Good. All right. Well, I could write. You're so much better teacher. So this is I love it. So if there's only 2 fractions, one fraction divided by a fraction, I can just multiply by the reciprocal, right? So this leads to one general way to do these kind of problems. Hopefully, by the way I said that, I'm saying that doesn't always happen. But this leads to a way to do this. So I just multiply by the reciprocal. Is that cool? And of course, it's nothing crazy because that's the x's are numbers. So that's how I do with numbers. That's how I do with variables. And then what can I do?
X, Y.
Yeah, one x dies, right? And one y dies. Anything else die?
Oh, minus 1. No.
Nope, nothing else dies, right? So then on the top I get x times this. I might as well you don't have to, so we'll just write it like this. X times this over 3 minus 2x is the only survivor on the bottom. Yes, ma'am.
Sorry. Why do you flip the denominator?
So
I understand you're multiplying the reciprocal, but you're
Yes.
not multiplying it by 3 minus 2x over x squared y.
because that's what it is. I have to multiply by its reciprocal. What's the reciprocal of what I'm divided by?
Oh, okay,
That.
okay.
Yeah.
Gotcha.
All right, cool. And I showed you, I can't remember when, the reason why we do that, right? I showed you that.
Yeah.
All right. And if you wanted to, you can multiply it in. It's not a big deal. Okay. Yay. So, if it doesn't start off that way, if you had a problem like this, for example, what, Jeff? I don't know, man. 4 over a minus 2 over b over 6 over a squared plus 5 over ab. Of course, what we're doing right now, in general, in this class, is developing the tools to be able to handle any equations that are thrown at us. So there are situations in real life, I know you don't believe me, but I don't care, because it's true, where something like this could happen, and you want to be able to simplify it so you can work with it, right? I'm not saying this is going to happen in everyday life. I love that question. This will not help you buy lettuce at the store, this skill. This will not necessarily pertain to your career that you want. But if you want a college degree, we think you should know things that humans have invented to get a college degree, and math is one of those things, right? All right, I don't know why I went off on that rant, but so one way to do this, method number one, and then I'll do the same problem with method number two. Method number one is to make this look like that, and then do what we did. And how do I make this look like that?
Don't you change this?
But see, that's the problem.
No, just divide.
How many fractions are on the bottom?
2.
2. I want you to realize the reciprocal of this is not a squared over 6. No, it's 1 over all of this. That's the reciprocal of that. I can't reciprocate a fraction until I have a fraction. I have 2 fractions. How do I get a fraction down there? And then I can reciprocate it. Get the LCD. I love it, right? And on the top I can do the same thing. So I have 1 fraction divided by 1 fraction, and then I can officially do that. So I want you to be real careful. If I have like 1 over x plus 1 over y, this is not equal to x plus y. Too damn bad. That's just not what it is, because addition does not play well with division. Yes, sir?
So we have to add and subtract before we can divide?
Totally. I love it.
Is that the only thing? Is defies PEMDAS?
Does not defy PEMDAS. Never does. Does not. Real quick. If you wanted to do this problem here, and you wanted to put it in your calculator exactly the way it is, if you put in your calculator this, is your calculator going to tell you the right answer? No. So what is it that we have up on the calculator? The calculator, TI graphing calculator, knows PEMDAS. It's not going to make an order operations mistake. It's us making mistakes when we put it in. What's missing there that we know is there because this big bar that humans can see, but the calculator can't see that big bar, right? Parentheses. I know the top is by itself. I know the bottom is by itself. So there's understood parentheses when we do the big-ass division bar. Right? But the TI 83, 84 doesn't have eyeballs. Maybe the TI 2000 will. And of course it's going to lead to Skynet and death and destruction. We have a little calculator with eyeballs. It'll sound like a good idea. Calculator, do that problem for me. And then the calculator, like, screw you, taking over the world. Shit. Oh, shit.
Here's the C4 for you.
And that's just the end of it, right? Oh, well, we had a good run. All right, is everybody cool with that? That's a really good question, though. I'm not trying to make you feel bad, but we often forget that this is something we can visually understand what it implies if I try to write it in one big line. All right, where am I? So how do I get an LCD here? What's he need? He needs a B, and he needs an A. So then I'll have 6B plus 5A over A squared B. Is that cool? Alright, and how do I do the top? What's he need?
B.
B. What's he need? A. Don't we all? 4B minus 2A over AB. Now that looks just like that. And some of you guys might love this method, which is great. Personally, I don't do it this way, but some of you are like, why is there another method? This is beautiful. And then we can just do it the same way we did up there, right? We can just take 4B minus 2A over AB times A squared B over 6B plus 5. Alright, is that cool? So this problem was a little bit easier because it started already as 1 fraction over 1 fraction. If you don't, one option you have is to make it 1 fraction over 1 fraction. And then what can I do here?
A's and B, and A and B.
1A cancels there, and 1B cancels both. And then anything else? I could factor the top, but I can't factor the bottom, so nothing would happen, right? So I'm not even going to do it. So I get 4ba minus 2a squared, because I'm multiplying the a in, over 6b plus 5a. Done. I understand as a student, it's always a little bit of a letdown when the answer still looks disgusting, but it looks a lot better than it did. Yeah.
When you do, does it matter with the A and the B next to the 4, which order they go in? Like, does it have to be 4BA or can it be 4AB?
Oh yeah, it could be 4ab. It's convention to write it alphabetical, but I just didn't want to.
Can't you cross out the 4B and 6B?
No, why? Because you're using division to cancel them out, but what are they a part of? Subtraction and addition problem. So division can't do that. Division can't break into an addition problem. And we know that. We know that if I had 4 plus 2 over 4, we know we can't kill those 4s. But the minute I throw some variables in there, you're like, well, that changes everything. No, it doesn't change anything. It can't. All right, cool. So here's, if you like that method, awesome. You can look away. You can stare at the wall. You can go, nah, nah, nah. I'm going to show you the second method. We're going to do the same problem. Let's see if I can remember what it looked like. And the textbook's got both of these methods in it too, so you have that as a backup. So the same problem, the different method I'm going to use. Here's what it started off as. This is the way I like better. Personally, that doesn't mean a damn thing about how I'm going to grade. You can do whatever way makes more sense to you, right? I won't take it personal. If you don't like it the way I like it, who cares? The way I do it, and the way that the book also talks about it, method number 2, the book calls it, is to look at all of the fractions at once. What's the LCD between everybody? That's one reason why students don't want to do it that way. I understand. So you don't have to.
A squared.
Yeah, so, yeah, a squared b, right? Everybody needs 2 a's. Everybody needs a b. Do you guys see that? So what's he need?
A.
AB. Abba, good. And what's he need?
A squared.
A squared. And what's he need? A b.
A.
What's he need? An a. And here's the beautiful thing. Here's what I can do now. Everybody is being divided by a squared b, right? You with me so far? I can already tell that a lot of you guys aren't going to do it, which is fine. Some of you guys will do it this way, which is nice. Now watch. If I multiply the top and bottom by a squared b, it'll cancel everywhere. So I'm left with 4ab minus 2a squared over 6b plus 5a. Same answer we got that way, just a little bit quicker. That's why I like it that way. I like quick methods. But you have to be able to realize that you'll have several more fractions to take into account at once. That's the step that actually makes this quicker, is I'm looking at all the fractions at once, instead of these two, and then I look at every... No. I do them all at once, and that's why it's a little bit quicker. You can do it either way you want to.
But we can't cancel B and A whenever you're multiplying.
Where am I at?
On the left side, left top side, and the bottom right side. Because you have 4B and then you have 6B.
Yes?
Why can't the B's cancel?
Because is the b multiplying the top? The b is a part of a subtraction problem, so division can't cancel it. Yeah.
Division can't break the fourth wall.
Or if you like chemistry, that bond is too strong for division to break. Hey, look out! All right, sorry. That's section 7.5 there, right? That's all it is. So it's those two methods. Both those methods are in the book. So let me give you one problem to try. So you got this here? So you guys try this problem here. And then we'll probably go on our little field trip. MN, yes. Probably not a good choice of letters for me, but too bad. Oh, you can do it, Jeff. Ooh, I like it.
Using number two.
Yep.
If you don't multiply everything, you know, as the n squared. I know you would do n squared.
LCD would be now and then.
And Q.
3. I like it.
Yeah,
Good.
so you multiply.
So give everybody enough to have
An
that.
n2 and an n.
No, because that would be end of it. He just needs how many more ends?
One.
One.
You just
So you wouldn't multiply by another 2. Right? He just needs 3 ends. He just needs 2 more ends. And then everybody needs 2 ends.
Okay.
Yeah. So the LCD is going to give everybody, whoever has the most stuff, he gives everybody that amount.
Okay, and whatever you do to the bottom one.
Oh yeah. And yeah, good. And if you factor it, it will do it. Is this the LCD? Yes. Check, he's got the same number. Thing on the bottom here. Is it a minus or is it a plus? That should be.
Oh, my bad.
Oh wait, am I looking at the right column?
No, you're not.
It was a plus.
I like that method you just showed us.
Yeah.
It's so much easier.
Yeah, you got it. Good.
Are you using number two?
Yeah.
Can I see that again?
So, the bottom.
Yeah.
Oh, the second one. Can't multiply by I'm going to see I'm better by here. Or combination. Multiply by.
Okay. So you need this is end of the third. So this is n squared. This is end of the third. You want to make all of them m to the second and n to the third.
Okay.
So this one, yeah. You want to see it has that two variables. You want to see which ones have the most power, and then those you want to make all of them combinations. So how this is m n, you want to see m squared n to the third.
And then you can just multiply everything by it.
Yeah. So basically, like with this one, you just give it one M and two N's, and you do the same thing with the top. Whatever you give the bottom, you give the top.
Yeah, okay, gotcha, thank you.
You're done. Yeah, so you just put that next to that, put that next to that. Multiply it. There's nothing else against it. Oh yeah, so now make this one fraction, make this one fraction. Now see how here, he doesn't need two N's, he already has one. So the LCD on the bottom is actually just N cubed, because then you just need this. I like you're making a bunch of stuff. Same idea on the top.
So this is gonna be this is gonna be
Yeah, but that means the top, this guy only needs, he didn't need anything. So there should be anything.
This, right?
Same thing. And this guy already had two, he only needed one more, so it should be just an N. Yeah. Same idea on the top, you don't, you only need two N's.
Oh, so do you just do it?
No.
You need an M. You need M squared.
He's got two N's.
Gotcha.
He's got one.
Because they all have to be M squared.
Yeah. Yeah, good.
And then what you do is multiply the entire equation by N third M squared.
Let's see.
The NM squared.
Some of you guys might realize, can you look at this? Let me see. Can you look at all three of these?
M squared and cubed.
All four of these.
Put it there.
And tell me what the LCD is.
N cubed N.
Yeah, N cubed and M squared. You should be able to do that. Because he's got the most N's, so you can give everybody enough N's to match his number of N's. He's got the most M's, so you give everybody enough M's to match his number of M's. The LCD is not n to the fifth, right? I like it. So you could make method number 2 a little faster even. You could just right now multiply everything by this. Yeah, so this would be n cubed m squared, so the m squares cancel. Some of you guys see that maybe. Alright. Yeah. So if you see that, you probably don't need me to show it to you, and other people get confused when I show it. So that's why I don't really show it that much. You with me? So if you want to do it that way, great. So let me try to do this both ways real quick. If I do it, method number 2, since I'm talking about it, he needs 3 n's, right? He needs an m and 2 n's. He needs 2 m's, I like it. And he needs
M squared N.
m squared and another n. So now everybody has this, so that I can multiply top and bottom by that. I have to do the same thing to the top and to the bottom. So I'm not picking on anybody, but I always have people that try to multiply the top by m squared n and the bottom by n cubed. No, you can't multiply top by 7 and the bottom by 3. You can't multiply by different things, right? All right, so then what do I get here? I get 7n cubed, because the bottom is going to cancel. Bottom's going to cancel, bottom's going to cancel, bottom's going to cancel, because I made them all the same. Why am I allowed to kill those bottoms, by the way?
Good.
If that wasn't there,
Because you're multiplying by it.
sort of. So if I said, figure out this, could you multiply by 5n and kill the bottoms?
No.
Because there's not another side to make it legal, right? You have to have 2 sides, either a top and a bottom, or 2 sides of an equation, which is section 7.6. So since I have a top and a bottom, I'm allowed to multiply by anything I want to, except 0. So I multiply by the thing that's going to kill all my bottoms. Does that make sense? Take that as you will. Yes?
You mean you can't, for the other example, you can't multiply the entire 7 over 5n, 3 minus, or whatever. You can only do like 7 and 5n individually and 3.
So all I could do is give this guy 5. There's no way to make this bottom go away, because what would legally let you do that? If I just multiply by 5n, I have changed my number. So somebody said, all right, we got $10. And you're like, I got an idea. Let's multiply that by 5, and now we got $50. Right? That's not going to suddenly, whoop, my well, it's a little bigger. I'm sorry.
No, I was just trying to, I think you just said it weird.
All right, I got you. And that happens a lot with me. So I get 7n cubed minus 3mn squared over 10m squared plus
3m squared n.
Ah. So that's where you should have ended up, whichever method you chose. All right. So everybody did method 1. Do you guys get the same answer? Good. I won't do that. Yeah. All right. Let's do this then. We're gonna do our little field trip. I can't lock the door, so take with you anything that you don't feel comfortable leaving behind. We're gonna go this way into the tech mall. So kind of go out the door, but go this way a little bit and wait for me to get in front of you, so I can kind of lead you around.